So on the airplane, I decided to make this. I was sitting in Istanbul airport, and I came up with these slides. So it might not be the most perfect thing, but hopefully you learned something new. So cool things about GKE that you might not know about. So who here knows what Kubernetes is? I assume most people. Yeah, OK. GKE is basically Google's hosted version of Kubernetes, right? Google Kubernetes Engine. So what is Kubernetes Engine? It lets you kind of create Kubernetes clusters and then use those clusters, right? Pretty straightforward stuff. It's been, timeline, 2015, as GKE was publicly available, so almost 3 years now. So it's been running in Google for a very long time. It was open source way back in 2013. So what, right? Everyone is doing Kubernetes now. Every cloud provider, big and small, has Kubernetes, right? So why is Google Cloud special? So I have 3 sections: infrastructure, networking, and tools. And it gets progressively less polished as the slides go on. So we'll start at infrastructure. So cluster creation, this still blows my mind to this date, how fast it is. So you write gcloud container clusters create, and you get a cluster, managed master, nodes, all that stuff, right? All done with just one command. And it takes about anywhere from 3 to 5 minutes to spin up a huge cluster, small cluster, it doesn't matter. That makes it really easy to create a cluster, run something, and then shut it down. I think a lot of customers forget that they can delete clusters very quickly too. You don't have to leave it running forever, right? So a lot of people spin up a cluster, run all their CI/CD, and then just delete it, right? And because it doesn't take like 20, 30 minutes, it just takes 5 minutes. It's very easy to do that. So that's pretty silly. Node auto update and auto repair. So this is something that is becoming the default on new clusters, but in the past it was kind of opt-in. So what does this mean? So auto update is kind of what it sounds like. You go from 1.10 to 1.11, does it automatically for you. That's pretty silly. But what's really cool is node auto repair. So what can happen is if something happens to your node, it kind of breaks out of the Kubernetes mesh for some reason. Kubelet goes down, kubeproxy goes down, something breaks in API machinery. It can actually detect that something is broken, and then destroy that and recreate a new node to take its place. That animation is wrong, but that's OK. Node customization. So we're hold on. So node customization is pretty interesting. How many people here have actually played with Google Compute Engine's custom node feature? Almost no one. So most cloud providers, you have to kind of say, I want this instance, right? So it's like a 2-core, 4-core, 16, 32, 64, and it just kind of scales in these buckets. And they have multiple instance families. With Google Cloud, it's a little bit different. You can just say, I want this much memory and this much CPU, and we'll make a custom instance that exact size. So the really nice thing about that is you can customize your CPU memory. You can put local SSDs, you can put GPUs, and you can mix and match any of these features, right? So there's not like 20, or there's not like 5 different GPU types, and that's it. You can take any machine and then attach a GPU to it. You can take any machine, attach a TPU to it, attach a local SSD to any machine, right? And it's across data centers around the world, which is pretty cool. So this lets you kind of customize those nodes any way you want. And then we can actually help you a little bit further with something called right-sizing recommendations. So here we can basically look at the average CPU and memory usage of your VMs over X period of time, and then say, hey, you're running your VMs too big, so you should make them a little smaller to save some money. Or hey, you're running your VMs too small, you're like throttling your CPU and memory, you should make them a little bit bigger. And we do that automatically for you, and you can click a button and get that updated very easily. So now you have these like recommendations and all of these like different features and stuff. How do you actually use it? Actually, not yet. Hold on. One more before we go there. The last one is preemptable nodes. How many people are familiar with preemptable VMs? How about AWS Spot instances? Yeah. So these are kind of similar to Spot. I think the actual AWS changed to be closer to what we do, which is you just get a discount up to 80% on the instance, and the catch is it only runs for 24 hours. Now you're like, that's kind of silly. Like my services need to have more than 24-hour uptime, right? The really nice thing about Kubernetes is because it's a managed, cluster, and because the pods on a Kubernetes cluster can be rescheduled, 12-factor app, they're supposed to be resilient to going down and up. If a node goes down, GKE will actually detect that and spin up another preemptible VM to take its place automatically, right? So you can have a whole cluster of preemptible VMs, and they get shut down, randomly. But because it's being managed at a cluster level, a new node comes up, and the new workloads, spin up on that node, and so you just save money as long as you're, conforming to a stateless application. So I've actually done testing on this, and I'm not able to see really any downside if you're running stateless apps. It's so fast to spin up new nodes and so fast to kind of reschedule that work. It actually acts as like a chaos monkey in your system for free, right? So instead of setting up a whole chaos monkey infrastructure, just run preemptible, and your infrastructure is so unreliably reliable that it does chaos monkey for you, which is really cool. But the really big thing is you save a lot of money. So you can run basically 3 times your cluster for the same price. So the last part about the raw infrastructure is node pools, right? So you have all these different options like GPUs and big nodes, small nodes. Not all of your workloads might need GPUs, right? So why would you attach GPUs to every single node in your cluster? Instead, you can create multiple pools of nodes that can scale independently, that can be shut down independently. You can spin up new ones. You can upgrade them independently, things like that. And you can schedule your Kubernetes workloads based on annotations to specific nodes in your cluster, right? So this makes it a lot. So if you say you have databases running in Kubernetes, you need a lot of memory. You can create very high memory instances and only run your databases on those nodes. For your normal web workloads, you can just spin up like 2 core VMs and assign those there, right? For your machine learning workloads, you can put it to the GPU instances. So that's really interesting. But what's more interesting is you can actually auto-scale all of these. Look at that animation. It's beautiful. You can't even tell that it's animating. You can actually auto-scale all of these independently, right? And you can auto-scale them with custom metrics. So not just CPU-based auto-scaling, but you can actually put any sort of custom metrics you want into Stackdriver, which is our monitoring platform, and then or Prometheus, and then auto-scale based on those metrics, right? So like number of requests coming in, any sort of application metric that you might have, you can scale on that metric, right? So it'll scale out the number of pods. When GKE sees that there's pods in the pending status, it'll automatically spin up new VMs to run those pods. So now we have all these nodes running in a single zone. The next thing that a lot of people don't know that we have is regional clusters. So regional clusters are actually really cool. Right now they're free. Basically, we run 3 masters for you across 3 different zones in a data center, right, or in a region. And etcd is replicated across all 3 regions. So even if a complete zone goes down, you have no cluster downtime. It just runs on the other 2 zones until that zone comes back up. And so you have high availability masters for free with this. Again, multi-zone nodes. So you can basically get another layer of high availability for free, right? And there's no difference to usage. You just say regional instead of zonal, and all the Kubernetes tools work the same. There's no difference in terms of usability. And so one of the newer features that is enabled because of this is something called regional persistent disks. This is something that I don't think anyone really knows about. Let's say that you have a database running in zone A, right? And you have it backed by a persistent disk. Pretty typical stuff. What happens if that zone goes down? We can actually detect that that zone goes down, and then what a regional persistent disk does is it actually mirrors writes to another disk in another zone automatically, right? So it's basically like writing to both disks at the same time. And so if that zone goes down, it'll actually just mount that new disk that's kind of that copy to a node in the other zone automatically, right? So you have like a 0 downtime database failover, basically. So this is actually what we use under the covers for our high availability Cloud SQL for Postgres. And we just give you that same technology so you can build whatever database you want on top of it. Upcoming, how many people run on-prem or in their own data center? 1 person, okay. So if you want to run Kubernetes on-prem and you want us to manage it for you, we have GKE on-prem coming soon, maybe next year. This basically lets you use the same Kubernetes tools that you use on Google Cloud, so the gCloud SDK, the Kubernetes dashboard, which I'll go into in the details in the very end, but on-prem, right? So your master and nodes all run on-prem, and it's just a connection back to Google Cloud to kind of manage that. So if you like the Kubernetes tools, but you don't want to run on Google Cloud, sorry, if you like the Google Cloud tools, but you can't run on Google Cloud for whatever reason, GKE on-prem is a huge thing a lot of enterprises are asking for. Okay, so that was like infrastructure. I still think that's kind of the more boring part. You can do a lot for cost savings, a lot for like infrastructure optimization, right? Where I think Google Cloud in particular is really powerful is in networking. We kind of built our network for containers, right? Because we run containers at Google. And when we came up with Google Cloud, with VMs and things like that, a lot of those features didn't make any sense because customers wanted VMs. But now, finally, customers want containers, so we're taking a lot of the stuff that we've done internally and then pushing it to Google Cloud so we can use. So you guys can use it, right? So the first thing, kind of fundamental, is this thing called IP aliasing. I like to call it VPC Native Pod IPs because it makes more sense. But the official term is IP aliasing. How many people have heard of IP aliasing? A few people. Yeah. Huh? No. So basically, like, okay, so if you spin up a Kubernetes cluster, right? The VMs get real IP addresses on the VPC, right? And they're routable by any other VM on the network or whatever. But the pods get these like VIPs, right? Virtual IPs that are only real inside the Kubernetes like network, right? So the problem is, there's a lot of problems with this, right? So if I have a VM outside of Kubernetes and I want to talk to a specific pod, I have to expose it with a service or a node port or something, and then it'll bounce around and finally find it, right? And the other way around, if I want a pod talking to an outside service, it'll get natted through the actual VM, right? So with IP aliasing, pods actually get real native IP addresses on the VPC, right? So they just look like any other VM from a networking standpoint. So this actually unlocks a ton of potential stuff. So this came out like a few months ago, and then a bunch of new features were built on top of it. So the first thing, I think this just became GA like last week. So see, hopefully you didn't know about this. So container native load balancing. So this is like how a normal load balancing works in Kubernetes, right? No matter where you are. So you have a load balancer, GCP load balancer, AWS, ELB, whatever, right? It'll send traffic to the VMs on a specific port, and then IP tables will take that and then pass it to the actual pod, right? So the problem with this is the load balancer just sees like 5 VMs. It doesn't see that you actually have 20 pods running on those 5 VMs. And so it'll just send it to like, it'll do a health check on the VM level, right? And it'll send traffic to one of the VMs. That VM might not even have the pod running on it, right? So then what happens? Then IP tables will say, oh, then take this and then send it to the other. So it's a double hop, right? And it gets natted through a bunch of stuff. And so it's not really nice because the load balancer doesn't have any knowledge about what's happening inside of the VMs, right? So with container native load balancing, we basically have something called a network endpoint group, which again is an arbitrary set of IP addresses. Turns out now that you have IP aliasing, you can give those pods an arbitrary set of real IP addresses, right? So you can actually give the load balancer the IP addresses of the actual pods, and it'll just send it directly, right? No IP tables magic, no double hopping, just direct to the pod. And we're able to do this because of our SDN, because we have direct control over like what's happening on the network. So this is basically for external traffic. We also have internal load balancing. All you have to do is basically set, let's see if this laser pointer works. Yeah, this annotation type internal, and so you'll get an internal load balancer instead of an external load balancer. And so if you have services outside of Kubernetes that you want to access a Kubernetes service, just spin up an internal load balancer. And again, it's using our SDN, so there's no box, there's no central point of failure. It's just our routers are doing it automatically, which is really nice. So you have no performance hit whatsoever. This came out yesterday or today. I don't know what time it is right now, so it's announced at Cloud Next London. This is really cool. People have been asking for this for a very long time. So one of the biggest problems with Kubernetes is the fact that it's very ephemeral, right? You have nodes coming up with different IP addresses. The pods have different IP addresses. A lot of legacy systems, unfortunately, say, give me your IP address whitelist range, and I'll accept traffic from only that range, right? And you're like, well, my Kubernetes IP addresses change all the time. What am I going to do? So we finally came out, and so the old solution was you spin up a VM that nats this stuff. Problem is, it's hard to manage that kind of stuff. It's not highly available. So we finally came out with Cloud NAT, which again, we just program our SDN to kind of like transparently change the IP address before it goes out to the internet, right? So if some legacy system that need a whitelist just a few IPs, you're going to say, NAT all of these connections to this particular endpoint, and it'll happen automatically on our network, right? No box for you to set up. It's just all done at the network level, which is cool. Another really cool thing is multi-cluster ingress. I don't think anyone except Cloudflare has this. So you have multiple regions around the world. You want to send your traffic to the closest region. How do you do that? With multi-cluster ingress, you get one IP address. It's any cast around the world. Traffic goes to that IP address, and we automatically route it to the closest data center. That's it, right? So you set up an ingress annotation. Right now, I use a tool called kubemci. We're hoping to actually put that natively into Kubernetes so you don't have to use any third-party tools to set this stuff up. kubemci is just a bunch of bash. Literally, that's all it is. In the future, it's going to be built straight into Kubernetes. But once you set this up, you get a single IP address for all your ingresses for all your different clusters. Right now, the clusters have to be running on Google Cloud. We hope to, in the future, let you kind of put it to like on-prem or different clouds as well. But for now, it's just only Google Cloud. This, again, is brand new, integration with all of this stuff. So in the past, our load balancer worked with all this stuff. There's no new features. But the really cool thing is now it's all natively done in Kubernetes. So you can actually use Kubernetes YAMLs and annotations and stuff to set up like Cloud CDN. So you can like push your static assets to Cloud CDN with just Kubernetes YAMLs. IAP, which is the Identity Aware Proxy. How many people even know what that is? Almost no one. Yeah. So IAP is actually what we called Beyond Corp at Google. There's a white paper written about that. Basically, we don't use VPNs to log into Corp network. Basically, you put this in front of a load balancer, and it'll put like your little like G Suite login, and so you can just put that in front of any application, and you have you can do remote access and stuff. You don't have to worry about firewalls and stuff like that. So that's really nice because you don't have to build that into your application. You don't have to build login kind of work if you have corporate applications. And Cloud Armor is DDoS protection. Again, you can just use native Kubernetes ingress annotations to set all that stuff up. OK, I think this is the last one for networking. So private clusters and master authorized networks. I always flip that around. So private clusters, a lot of people have been asking for this. Right now, in the past, you have to have public IP addresses for your master and public IP addresses for your nodes. People don't want that. They want private clusters that no one outside of their corporate network can access. Okay, so private clusters, right? No public IPs for masters or nodes. But of course, that's kind of like the like most secure, right? No public. Sometimes you do want public access, but your master, you don't want some random guy on the street to try to like SSH into your master, right? So you can say only these IP address ranges can talk to the master node. Okay, almost done. Monitoring and tools. This is where the slides start to get really bad. This is about like 6 o'clock. I was like, I had 4 hours to sleep, and I was like, all right, let's finish these slides. Okay, so Stackdriver Kubernetes monitoring. This is brand new. Again, so Stackdriver was built for VMs. Now it has native support for containers, so you can actually drill down into each container, not just the VM level stats, which is really nice. You can see the beautiful layout. Container registry, right? So container registry, if you use GKE, use container registry. It's where you push your containers. One really cool new feature that we have is vulnerability scanning. So you can actually scan your base images for known CVEs and then alert you on those, right? So here I have one based on Debian, and it's really old, right? So this is like from 2017. The older the container, the more vulnerabilities are found, right? So you can see it has a bunch. This one is based on Alpine. You can see it has much less. If you build one today, hopefully using like the most up-to-date stuff from Docker Hub, you will have 0. But as time goes on, you can rerun these scans, and you can see your older containers, have vulnerabilities. And if they do have vulnerabilities, you can use something like Cloud Build to kind of kick off a serverless build and build a new container, right, fresh one. So Cloud Build is kind of our bare bones, CI/CD product. I don't know if I would call it true CI/CD. It's more just for build steps, basically. You can hack it to do CI/CD very easily, but there's other tools out there. Basically, you can set arbitrary steps. So each of these steps is a Docker container. So you put whatever tools you want into any Docker container, and basically the working directory gets mounted into each of these containers, step by step by step, right? So let's say your first step is you want to run Ubuntu with curl for some reason, and then run some bash script. Once that's done, you want to put it into a Docker builder, and then build the Docker container, and then push it to a GCR registry, right? And so these can be triggered on pushes to GitHub, a pub sub topic, whatever, right? So it's a very easy to use CI/CD pipeline. It's 100 build minutes a day for free, which is more than enough for 99% of people that I've talked to. And it's really nice. I use it for a lot of things because it just automates. I just do a git push, and it builds my container for me and deploys it. OK, almost done. So GKE dashboard. This is something that people take for granted. This has actually changed quite a bit from the past. In the past, you could just see your clusters, and that's kind of all you have. And then we used to use the open source dashboard. How many people have heard of the Tesla hack? Tesla, yeah, a few people. So they were running Kubernetes 1.4, which was at that time 1.8 was, what was fresh, and they had their their dashboard completely unsecure, right? And so people started mining cryptocurrency on Tesla's clusters. So by default, we do not expose the Kubernetes dashboard at all anymore. I think you actually have to explicitly install the dashboard, the OSS dashboard, if you want it. Instead, we take the same stuff and we put it into the Google Cloud Platform console directly, right? So this gives you all the IAM, access control, all that kind of stuff that on the project level that you already set up for your organization, and so you can just use it for your Kubernetes clusters, right? So here we're looking at our workloads. So this is just the pods, but both jobs, deployments, pods, whatever you run here. Clearly, I was running Istio when I took the screenshot, and then also for services, right? I think there's one. Oh, I cut it off. There's also what we call the marketplace. So typically the marketplace was for VMs, right? So you can I want MongoDB. So you click it and it'll spin up MongoDB. Now we actually have support for container workloads as well, right? So if you say I want a Cassandra Kubernetes Helm chart, you just click a button and you can actually get it deployed into your cluster. And if you are working with someone who wants to charge you, let's say wearing a Datadog shirt there, right? So Datadog, if you want to run Datadog on GKE, right? It's a paid subscription. You can actually just pay that bill directly through the Google Cloud bill too, right? So the billing is all taken care of in one place, which is nice. Service broker, last thing. We have a lot of other services that you might want to use. Kind of annoying to set it up outside of Kubernetes, right? So you have your operations team have to take care of setting all this stuff up. With the open service broker, again, this is open source interface. So a lot of open source projects, other cloud platforms and ourselves, we all use this open service broker to kind of provision other resources on Google Cloud and then kind of natively give you the credentials and the bindings inside as Kubernetes secrets, right? So you just use those secrets and then talk to the services. So you don't have to set up, IAM credentials and keys and all that kind of stuff. It happens for you automatically, which is really nice. So your developer can just mount a secret, uses it. Your operations folk can actually provision the services, and they don't have to, coordinate, which is really nice. Okay, 2 new things coming up. If people are interested in Istio, we're having a managed version of Istio that runs on Kubernetes. So you click a button, you get Istio in your cluster. It was announced as alpha. It should go beta sometime soon. And more, we're going to take the Istio control plane and then manage it for you automatically, right? So right now, it runs in your cluster, but we actually want to take it out and run it ourselves, which is less work for you. Serverless add-on. It's called Knative. It's kind of what it builds on. But we want to give you the same Google Cloud Functions capabilities, but on Kubernetes. And the reason why is a lot of people, App Engine, we're it runs great on Google, but if I want to move away or run multi-cloud or hybrid, it's impossible, right? So with GCF, we want to, or for a serverless stuff now going forward, we want to have an open source version of it too, right? So you can run it wherever you want or on us, doesn't matter. Okay, done. Now I can go to sleep. No, just kidding. If you have any questions, yeah, just come find me after yours talk. Happy to answer whatever questions y'all have. Yeah, thanks. Oh yeah, and I have stickers too. If anyone wants stickers, I'll put them on the sticker table. Yeah.
So thank you. So actually we'll just switch the slides, and Ihor will present about CNCF.
Works. All right. Sorry about the brief delay. Welcome, everyone. My name is Ihor Dvoretskyi. I'm a developer advocate at the Cloud Native Computing Foundation. And today I'll highlight to you what we are doing at CNCF, what the projects are at CNCF, what actually was the Cloud Native evolution, what was the path, how we've started working on these projects. And thanks, Sandeep, first of all, for your great intro to the Google Cloud-related services. And actually, Sandeep highlighted a few of the projects that are CNCF projects. They are the Google products, but based on the open source projects that are the part of the CNCF ecosystem. So if you have any questions, feel free to follow me on Twitter and ask them directly on GitHub or any other source. I'm happy to answer them for you. All right, so let's start from the beginning. What we had at the beginning of this world, of the pre-cloud native era. So on this slide, you can see the evolution, how we moved from the early days of the IT environment. I'm sorry about this slide. I see that it's really difficult to read from the audience, but we'll share the slide deck later. So at the beginning, we had the non-virtualized hardware. At the beginning, we had only the pure bare metal machines, and the only way for you to run some kind of application was to install the operating system on that machine, possibly manually, to install some kind of software on it and run that applications, again, almost manually without almost any kind of automating tools. But after that, companies like VMware and others, they've started moving to the virtualized world. So VMware developed the virtualized solutions. How can you run the multiple bare metal machines that are virtualized on the single bare metal machine? So how can you run, for example, Windows applications and Linux applications on the same physical machine? How can you virtualize your workloads? How can you virtualize your networks? And how can you virtualize your storage on the same machine again? But it was not the solution for everyone. So not every company in the world is able to build their own data center, even if they really require their own data centers. And even in the specific cases when you are a small company, but sometimes you have to handle the huge load. For example, you are the small retailer, but right before Christmas, you have the huge load up with your customers, and you have to scale up with your current resources. So you will definitely will not buy any new bare metal machines installed into your data center just to survive during the peak period of 2 weeks before Christmas. So AWS was the pioneer in the market of the infrastructure as a service. So with the ES services, with the way when you simply pay per hour or per second to some company for their computing resources, you receive these computing resources. But if you don't need them, you don't use them and you don't pay any money. So AWS was the first company on the market, and other companies, again, like the Google Cloud, were their competitors. And having the ES system today is the extremely preferred way for you to handle your workloads. So less and less companies are using their own bare metal data centers for handling their workloads, but way more companies today are switching to the public cloud world. But if you are a developer and or if you are, for example, a small startup or middle-sized startup, and you don't want to maintain your own infrastructure, but you have to run your code somewhere. So Heroku developed the way how can you simply run your code somewhere. It's called PaaS, Platform as a Service today, and with Heroku and similar services, you simply order, like again, the billable hours from one company, and you can simply run your code there. If you don't need to run your code there, you don't pay them money. But if you'd like to use, again, the virtualized infrastructure in the similar way as you can use AWS, for example, or Google Cloud or Azure, but you still need your own data center, OpenStack came to the market. It was in 2010. It was the great solution in people's minds. So OpenStack was designed to replace AWS and other commercial vendor solutions in the public space. So if you have your own data center, if you have your own machines, you can now run all the workloads, provision your own infrastructure, provision your computer resources, provision your networking resources and storage resources with APIs that are delivered by OpenStack. Unfortunately, today OpenStack is not so popular for multiple reasons, but we will not cover the topic now. Another approach for you to run some code on your own infrastructure, the same way as you could do with Heroku and other commercial companies, but on your own infrastructure and in a free way, in an open source way, is Cloud Foundry. So Cloud Foundry is yet another Linux Foundation project, a CNCF. And Cloud Foundry is the foundation and is a set of technologies that allow you to run your own code on your own in your own data center, on your own bare metal machines, or somewhere in a public cloud, for example, on AWS or Azure or Google Cloud, using again the standard APIs, the standard way of interaction with these tools. But later, the biggest issue in the industry related that how can you bundle all your software into some piece that can be easily shipped somewhere, that can be run in the same way on your, for example, local machine on your laptop, and in the same way as you can run this piece of software somewhere in a public cloud like Google Cloud, for example. So a company called Docker, they developed a tool that allows you to bundle your software into containers, to ship it everywhere. You can run the software that is bundled into Docker containers in almost every machine where you can run Linux today, because almost every modern distribution of Linux supports Docker. So you can run Docker containers everywhere. And it was the great revolution for the cloud native space, because now you shouldn't deal with the software dependencies on your host machine. Now you should not deal with some possible conflicts, and now you should not deal even with some issues like hardware compatibility and so on. So if your machine allows you to run Docker there, you can run Docker containers there, and you can easily develop some software using Docker containers in your local machine and run them in your production. So that was the great move forward with the approach of delivering software, developing software, and running the applications. But the biggest problem with Docker was that it's not easily scalable. So you can easily run Docker on your one laptop, on your one machine, on your local machine, but it's not so easy possible to run all that software that you can run on a single machine in a huge cluster like 5,000 node cluster. And different solutions appeared in the market. So many of you could hear about Docker Swarm, the in-house tool developed by Docker INC, that is natively compatible with Docker runtime and is the easiest way to spin up the basic cluster to run some kind of software on the distributed machines that can be deployed in different data centers and so on. You could hear about Mesosphere and Mesos, again, and other tools that allow you to do the same. And you definitely have heard today about Kubernetes. So Kubernetes today is the leading solution that allows you to run containers almost everywhere, at almost any scale, with almost any kind of public cloud provider. And at the beginning, and in 2015, so it was the beginning of the CNCF, of the Cloud Native Computing Foundation story, and that were the early days of Kubernetes as the open source solution. So Google developed Kubernetes internally. Google open sourced it in 2014, and the whole year they've been evaluating the use cases for using Kubernetes in production. And in 2015, their first major version of Kubernetes was released. It was version 1.0. And exactly at the same time, the Cloud Native Computing Foundation as the independent organization was announced. So Google donated the code of Kubernetes, the trademark of Kubernetes, and all the related assets to Linux Foundation. And at Linux Foundation, we founded the Cloud Native Computing Foundation. So it's a common question why, so Kubernetes was the first project of CNCF, Kubernetes was the seeding project of the CNCF, but why this foundation is called as Cloud Native Computing Foundation? I'll have an answer on this in the next few slides, but I have to mention that CNCF today hosts more than 20 projects that are in a different way related to Kubernetes. But again, Kubernetes was the beginning of the story. So Kubernetes, again, Kubernetes is the major project and the biggest project within CNCF. And there are multiple reasons for that. So last year with the new stack, hopefully some of you have heard about new stack, is the industry leading media. So CNCF and the new stack, we've conducted a survey where we asked the respondents that are using Kubernetes clusters in production or in any similar use cases, how they use Kubernetes and what are, actually not Kubernetes, so what are the tools that are using in production to run their containers. And Kubernetes was the top solution. And even on this slide, again, I'm sorry about the small font, but even on this slide, you can notice that last year we had 69% of respondents that have been using Kubernetes, plus 17 respondents that are using Google Kubernetes engine, which is also built on top of Kubernetes. And even here, you may notice OpenShift, which is yet another commercial solution that is built on top of Kubernetes. So Kubernetes today is really the dominating technology in the container world. And almost in every kind of cloud or bare metal environment, you may find Kubernetes as the primary solution for running your containers. All right, so what do we have today? So today at CNCF, we've developed a few tools and a few visualizations. How can you First of all, get started with CNCF and get started with the CNCF technologies. What is your path as the beginner? So if you are a potential user and if you're evaluating the ability to run some kind of software in some way, and if you're looking for some orchestration software, like container orchestration software, if you're looking for some solutions for monitoring, logging, building the distributed storage and databases. So if you're interested in messaging, so all these projects are within CNCF. So we have solution to almost every kind of your question within the cloud native space, and we've developed this this brief tool and a brief visualization that is called the cloud native trail map, where you can find all the currently existing solutions under CNCF umbrella as the answers to your questions. Another great picture that you will definitely will not able to read from any place here. It was much smaller 2 years ago, and it was much easier to show you on the slides. But you may visit the link l.cncf.io or landscape.cncf.io from your mobile phone right now, and you'll find the interactive version of this. So what is this? What is the cloud native interactive landscape and the cloud native landscape itself? So on this slide, you may see all the solutions that exist on the market. These are not only the CNCF solutions, but all the solutions that can be called as that can be named as the cloud native solutions. So if you're looking for some tool, for example, for container orchestration, you may find here Kubernetes, which is a CNCF project, but you can also see here Mesos, Docker Swarm, Amazon service for running containers, and so. You can also find, like if you're looking for some networking solutions, you can also find here. Storage solutions are also here. So everything every solution that you can be interested in is on this slide and is on this web page. But again, we had a problem that when we are showing the presentations with this slide, people cannot read them. So we've decided to develop the interactive version of the landscape. So right now, if you are visiting this website, the l.cncf.io, you'll find all these technologies, but in a much more readable way. Also, you can sort the solutions. For example, here, if you're looking for only open source solutions, you can find them. If you're looking for only open source solutions, for example, that are licensed only with Apache 2 license, you can find them there. If you're looking only for CNCF projects or not CNCF projects, you can find them also there. So please visit this link, and I strongly recommend you to bookmark this link if you are building some kind of cloud native technologies and cloud native environments, because on this web page you'll find any solution that you can be looking for. All right, and what is the most important at CNCF? So the most important for us is the community. We're building the community, all the projects are open sourced, and we're interested in having people who are contributing some code. We're interested in people who are contributing not only code, but also documentation or running tests or even like simply providing the feedback. All the projects of CNCF, again, they are open sourced, and all of them are open for contributing. So if you're looking for any solution, if you're looking for contributions to the open source world, I strongly recommend you to start with the CNCF technologies, with the CNCF projects. And that's all from me. Any questions? Okay. Well, I probably missed the slide. I missed the slide. Okay, I removed it some way. All right. So the CNCF projects, all the CNCF projects are subdivided into 3 major groups. So we have sandbox projects. Sandbox projects are more young, less mature, And the projects that are currently mostly evaluated in the open source space. For example, if you heard about projects like SPIF or SPAR that are security solutions for the container world, or for example, cloud events, which is a specification for serverless. So we have the sandbox projects that which are the part of CNCF because we are providing them a home to be more mature and to be able to grow in this ecosystem. So if you have your own cloud native related project, you can show it to you can present it to CNCF TOC. TOC is a technical oversight committee which consists from different community members from multiple companies, and TOC makes the decision if this project has to join CNCF as a project or it has to work on some stuff. So the typical way for the young projects to join CNCF is to join Sandbox. Another tier of CNCF projects are incubated projects. So most of the projects that you can see on this slide are CNCF incubated projects. So for example, Helm or FluentD or Envoy are the projects that are really well known today in the open source community. They are currently they are mentioned as the incubated project. Incubated means that you have to be a bit more mature project, and the next step for you will be a graduation. And this year we had the first project that has ever graduated at CNCF. It was Kubernetes. The next project was Prometheus. So Kubernetes graduated in March. Prometheus graduated in August. And being a graduated project means that you reach the top goal of being a CNCF project. So you reach the highest level of community recognition, the highest level of end user consumption, and so on. The biggest difference between all these 3 tiers that, for example, sandbox projects, they can be maintained even by the single company with the goal that they will build their own community around this project. So if you're donating your project to Sandbox, it means that CNCF is not, we are not actively providing a marketing and promotional support for our Sandbox project. We're simply providing for you the vendor neutral space where you can grow number of your contributors, grow the number of your end users. And after you'll do it, you can grow up to the incubated stage. And after being an incubated project, you can be a graduated project as Kubernetes or Prometheus, which are well known in the world today. Any other questions? Yep. Mm-hmm. So CNCF was founded in 2015, as it's mentioned here. So in 2015, Google donated Kubernetes to the Linux Foundation, and again, we've decided at Linux Foundation to build a cloud native computing foundation as an independent foundation under their Linux Foundation governance. So the beginning of the CNCF story was approximately the same time when Kubernetes 1.0 was released. The relationship with Apache Foundation is a bit tricky. So we are not the direct competitors because we are in the open source. We are not the commercial companies. We are not the rivals. At the same time, if you're looking for some kind of foundation and for some kind of governance for your open source project, and you don't want to run it on your own, you can decide between multiple foundations, but definitely Linux Foundation and Apache Software Foundation are the biggest ones here. We have different ways of managing our projects, so we are less way restrictive to our projects. What should they do? So CNCF staff is almost not responsible for any kind of governance on these projects. So we are mostly are mostly interacting with this project as the general, like the regular contributors, or we're providing them some kind of marketing services, legal services. For example, Linux Foundation owns the trademark of Kubernetes, and that means that, for example, if you'd like to run some kind of event that is called, for example, Kubernetes Day, or any kind of mentioning Kubernetes in their name, you have to ask Linux Foundation before doing that. Or if you'd like to build your own commercial product on top of Kubernetes, you also cannot do it with Kubernetes because we own the trademark and so on. So in this way, we're protecting our projects from any kind of issues that may happen with them. But the code base itself is developed not by CNCF staff. So I'm not developing Kubernetes first of all. So I'm a contributor to Kubernetes. I'm acting within multiple areas of Kubernetes, but I'm not contributing code. So Kubernetes community that consists from multiple members from vendor companies, they're developing code. So we're mostly providing the support and solutions for them. And that's one of the areas where Apache Software Foundation is can be compared to Linux Foundation because they have different governance policy there. Okay. I would adhere serverless. Yes. So the next way, I would adhere Istio and serverless solutions like Knative that Sandeep mentioned today. So Kubernetes is an extremely powerful solution, and it can handle almost all your questions, but it cannot satisfy you. It cannot satisfy you if you are looking for some solution to run your workloads, because the complex solution for running your workloads has to include some kind of service mesh. It has to include some way how can you run this code. So if I'm an end user, if I'm using an application and for example, I'm clicking some link in a browser, I don't care if it's Kubernetes under the hood or if it's just a Windows machine there. So I would say that serverless and other tools that allow you as a developer simplify your interaction with these tools should be the next step. And we'll definitely add it there. Any other questions? Okay. Mm-hmm. So we have a serverless working group within CNCF. And the project they have released, so every working group within CNCF has to deliver something. And the major requirement for them is to eventually deliver some projects. So the serverless working group has delivered a project called Cloud Events. Today it's a sandbox project. So it's not really mature, but it's still an evaluation of the serverless standards and protocols. But we are moving forward to build also the reliable way for you as for the consumer to use serverless technologies and to use them in an appropriate way. Because unfortunately, the landscape of the serverless technologies, we have it here. So we have a landscape in a landscape, and it's even smaller. So the serverless landscape is like the half size of this landscape. Again, please check it here on l.cncf.io. You'll find tons of serverless solutions, and the biggest problem today is most of them are not really easily compatible with each other, and you can use multiple solutions for solving different needs. But today in the serverless world, there is zero huge and there are no huge solutions like Kubernetes that is like Kubernetes today in the cloud container orchestration space is the really preferred solution for almost everyone. There are no similar solutions in the serverless world, There are even multiple solutions that you can run on top of Kubernetes, but they're different. So for example, kubeless, Knative, OpenFast, they are all different, but they are all designed to be run, to be used on Kubernetes. So the goal of the serverless working group at CNCF and the goal of the Cloud Events project is to define the standard architecture, to define the standard reference design for building the serverless architectures. So we don't have the single project, but we are going to allow different projects to be much more compatible with each other. Any other questions? Perfect. Thank you.